Hi there, so I'm James Alliban, and I'm going to be speaking about augmented reality in education. So, a little bit of background. I work for a company called Skive. We're a digital agency in London. I'm their augmented reality specialist. We're mainly known for our Flash games and websites. We do a great deal of other things with mobile and other web technologies. Yeah, a great deal of augmented reality stuff at the moment, which is great because I like it. So what is augmented reality? So I always like to start off with a demo. So if I just pop over here. So this is one of the first things I ever made, actually, and by far the most popular. It was the AR business card. Now, essentially, augmented reality is overlaying computer graphics onto real-life environments. Oh, you don't need to hear all that, do you? Let's get rid of that. So what's happening here is the computer image is being tracked and analyzed by the software. You've got this little thing here, this fiduciary marker, and it's basically telling the machine or the software how to rotate and position and scale a 3D model. In this instance, I'm analyzing a video feed of myself doing a talking head video and creating this crazy 3D pixel mosaic effect using the brightness. So that went down very, very well. That was just something I did in my spare time and kind of launched my career, which was nice. So as a result of that, I'm an augmented reality specialist all of a sudden, which is a great title, dinner parties. So let's get back to keynote. So yeah, so a lot of people think that perhaps this is augmented reality. You've got the football game with the score and the information about the players overlaid, or perhaps this, you've got your live news feeds coming in over a live news broadcast. But there needs to be really an element of tracking. So this is very similar to what I just showed you, using a fiduciary marker. Yeah, it really needs to feel as though the computer graphics are actually part of that real-life, live, real-time scene. This is another application, so you can actually use, I mean, there are many different applications here. This is using face tracking. These glasses are superimposed on top of the person who is standing in front of the camera. This is a Ray-Bans application. Absolutely just fantastic. I mean, I think I bought a pair of Ray-Bans later on that day, actually. Very susceptible to those kinds of things. This is one of the applications I made. I made this about 2 years ago using processing, which is an open source framework for artists and designers. And what I'm doing here is using color, using the green from the glove as the marker in a sense, and I'm throwing these ribbons around the room there. Lots of fun that was. So you can also use, I've used my mobile phone here as well, so you can basically just select any color and then track it. Yeah, that was really effective. I got a great deal of great response from that. Also geolocation, so I'm sure a lot of you have seen this. You can hold up your phone, smartphone, it'll figure out where you are in space, use your compass to figure out where you're facing, and then overlay information about the local area on top of that. So this is the nearest tube application for the iPhone, that's very useful at the moment. And just recently, the iPhone, it's been available on the Android for a while now, but the iPhone, you can actually analyze the camera feed in real time and then track things like markers, like faces, and so that's very exciting. There are a great deal of interesting applications coming out for that as well. Now, this is something that not so many people associate with augmented reality, but it clearly is because it's the combination of computer graphics and real life in real time. So, I mean, that's what it's all about. It's called projection mapping. And this has just become huge over the last couple of years, and I'd really recommend looking into it. It's the whole idea of projecting light onto an object and making it look as though that object is coming to life in some way, or other objects are interacting with it. And absolutely, please have a look for this online. It's incredible. So just to kind of go over the point again, what's happening here, this is from Total Immersion, this diagram. You've got your augmented reality marker there. It's being tracked by a camera, which is connected to the computer, which is running AR software. And then, as a result of that, 3D graphics or some sort of computer graphics is being overlaid on top of that content. So there's a great deal of interest across a wide variety of fields at the moment in AR. And I mean, it's being used in things like marketing and advertising, retail, education, art, military, there's medical, there's travel and navigation, as we've seen, gaming, loves it, there's manufacture, publishing, architecture, entertainment. The list clearly just goes on and on and on. And I think Ray showed this video earlier, but I'm going to show just a bit of it anyway. This is the brief, this is the future technology video from Microsoft, and just kind of have a look at it again. But think about overlaying computer graphics on real life here. There's plenty, like this one, for example, plenty of examples in this. Oh, hello. So you've seen this already, I'll move on. So this is a project I was involved in last year. It's called LarnGear, and it was basically a set of tools for GCSE students to learn about a range of different subjects, all that kind of fit in with the curriculum. I did this, I think it was about 8 months ago maybe. So I'll just take you through it and talk over it. So this is for biology, so you can just hold up the marker there, have a look at the organs. This is something you can use in the as a teacher in the classroom, or give it to the kids to take home, and they can use it in their spare time. So this is still biology, just going a bit further in and having a look at the heart, and just seeing how it pumps and the various different arteries that are actually there. We also made a few multi-choice games. This is from mathematics, quite a difficult one to think about in terms of AR, but we made this collection of shapes with all the measurements, and you have to try and figure out the surface area or the volume using the formula, and then just hold up the correct card. Religious education as well. We tried to introduce the kids to Sikhism. So we're showing them the 5 Ks of Sikhism here. Now, you can hold the marker up and tell you a bit of information about that particular item, why it's relevant. If you put it next to the pupil, he will wear this item, like this pair of pants here, which he will wear just now. There you go, overlaid, like Superman. This was for physical education, like very good for doing things with the body. I mean, clearly, because you're actually in front of the camera yourself. So this was just to show the contraction of the muscles and the names of the bones. Now this is an interesting one. I learned while doing this project that kids no longer do practicals in chemistry in school, something to do with throwing chemicals at each other or something. They don't like it. So, so we can now actually do this, and we can actually show how metals and solutions can combine and what happens. This is another multiple choice. So this was for English, so you have to figure out what type of word is being displayed and then show the correct marker. This is another one. This is one that got a lot of attention, actually. This is for radioactivity and physics. So again, something you can't expose kids to gamma and alpha anymore for some reason. So, you've got your source, you've got beta, gamma, and the other one, alpha, and you've got your Geiger counter. Now, you can kind of see in the corner there what the reading would be, and then you've got a range of different materials, such as paper, lead, excuse me. So you can put that in the middle there, and it will show you how that particular material will affect the reading. Another multiple choice. So we've got languages here, and you're just trying to figure out what the kid is wearing, what the child is wearing. So 300,000 students were exposed to this, 80,000 teachers. Unfortunately, we don't have any results. I didn't take any questionnaires, but I met up with Paul Hines of the SSAT recently. It was through those guys. And he told me that kids and teachers alike were absolutely amazed by this technology. And they found that it just engaged the students. It's fun, it's game-like, and students really responded to it. So that was fantastic. So it's great to hear that it was a huge success. This is actually it's another project. This is being used in Thailand. Now what's happening here, each marker corresponds to a different molecule. So you can actually move specific markers over those molecules to find out about the different properties of them. So that was really useful. And then I think you should be doing it now. You can hold the marker up to the camera there and then find out information about that particular molecule. So there we go. So thankfully they did do some questionnaires. So they asked a range of teachers and students how they got on with it, and asked if they agreed with certain statements. So 62 science teachers and educators They were asked if AR aided the teacher in explaining the subject. 71% strongly agreed. The rest agreed. Students, they asked them if this helped them to better understand the concepts. 65% strongly, 31% agreed, and 6% were in the middle. Now they asked the students again if this makes learning more interesting and attractive. 87% strongly agreed, 12% agreed, and 2% were in the middle. Great results, I think you'll agree. Now, higher education. Now, I searched high and low. I couldn't really find many examples of it being used in higher education at the moment. But I did find a few examples that I think you'll find interesting. Now, this is using potential future technology, which is the AR goggles, which overlays content directly onto the glasses themselves. Now, what's interesting here is he's actually using the book as the marker. You can see buttons arising and coming up. Now, many technologists kind of think that when a new media form comes about, that you have to completely divorce yourself from any previous media forms and come up with a brand new set of codes and conventions, that kind of thing. I'm not sure I agree with that, and I've read a great book called Remediation by Jay Bolter and Richard Grusin, I believe, and they kind of agreed, they didn't agree with that either. They kind of think that really it's best to look backwards to these previous media forms, because I mean, the codes and conventions and the ways of using these things are so, tightly entrenched within our society that you can't really afford to ignore them. And it aids the transition between different media and just makes it much more user-friendly experience. I mean, it kind of reminds me of the iPad motto, or the strap line, which was, you already know how to use it. And you do. I mean, you pick up an iPad and you go to the iBooks, and it's not really new. It's really mimicking the physical aspect of the book. You're turning pages. Clearly it's looking back to the book and trying to replicate that. So this is actually a form of training. So this isn't actually being used in universities, but it's being used for Volkswagens. But clearly this is the kind of thing that could actually be used in higher education. So he's using goggles here as well. Now this isn't overlaying the information directly onto the glass. He's got a camera in the goggles. He's got two screens, one on each eye. And the information is being fed to him by mixing those two, the camera feed and the 3D stuff. So what's happening here is object recognition. So it's finding out where that grill is and telling him that for this particular procedure, he has to take off that grill, showing him where to take it off and how to go about the entire procedure. It's being used a great deal in medical as well. Now this is a situation whereby you can actually see the bones in the foot. So it's tracking the leg. You can see these little devices on the leg there. And you can actually see it from all angles, and it gives you a great understanding of actually what's underneath the skin there. Same thing for the muscles. This is to do with brain surgery, which is nice. So it's shows you how to do, so if you're into that. So it shows you where to make the incision. It shows you what you need to do throughout the entire procedure. Now the next one's got a bit of surgery in it, so if you're a bit squeamish, please turn away. It's not too bad though. So now this one is a throat operation. That's currently being used. The white thing here is a camera. It's being poked around in the throat. It's basically looking for the affected areas that need to be dealt with. So he'll drop a little kind of digital nugget in there, and then you can track it as he moves in and out. So it just kind of means that you don't have to kind of find one and then deal with it, find another, then deal with it. You can track them all, and it's just a big time saver, which is good in surgery. So why is AR effective in education? Memories. Now, clearly, higher education isn't all about memories. It's about creative problem solving, various other things, but memories clearly are a big aspect to it. So I read a great paper recently called Making Memories of a Lifetime by Hughes and Stapleton. And they basically compared AR to a range of different forms of entertainment. Their whole idea is that basically that real-life situations are far better at actually creating lifelong experiences, lifelong memories than say films and other things. So yeah, basically there's things like passive media, and clearly that's something where you just sit down, you absorb it. Things like films, television, and it's because it's from like a completely other time and place. It's not really immediate. It's not really experiential. We've also got things like live theatre. Now, Obviously, the proximity, the distance between the actors and the actual audience, much smaller, and it's live. And I suppose you could say it's slightly immersive, but it's not quite that really very experiential. Video games, clearly very interactive, very immersive. It's great, you can play, and it's all that. But it's essentially what's happening is you're interacting with a world that is from another, sort of created by someone else somewhere else. Now, they seem to think that AR is closest to, in terms of entertainment, it's closest to live role-playing games. So things like the Murder Mystery Weekend, the live reenactment of battles, things like that. Things where you can actually shape the experience and the narrative and create your own stories and branch off into different directions. Now, AR for me and for them really is the closest in terms of technology to a real-life experience. I mean, you've got the immediacy, you've got the experiential nature of it. You're actually interacting with the real world and computer graphics. So they found that in terms of their hypothesis that that this is actually the closest you can get to real life, and hence it's running out of time. Closest you can get to real life, and hence the best for making and long-lasting lifetime memories. So let's have a little look into the future quickly, the future of what's going to happen with AR. We've seen this video already, Xbox Kinect. I think it's got great potential for AR systems. Now, usually when you're with AR, you're analyzing a 2D image or a series of 2D images from a camera. And fair enough, you can track patterns, you can track colors, motion, all these different things. But essentially, it is a 2D image. Now, what's happening here is it's actually figuring out where all the items are in the room, all the depth of everything that's in the room. It can figure out where humans are, well, that's all done in the software, and it can tell what gestures they're using, and then map that to the actual game itself. Google Goggles. Now, this is an Android app that's been out for a while now, and I was amazed when I first used it. You can actually take a picture of a person, a place, or an object, send that off to Google, and it will come back, and more often than not, it will recognize it and give you information on it. Just imagine that combined on a mobile device with GPS and augmented reality, walking through Paris, you show it to the Eiffel Tower, and almost instantly it recognizes what it is and overlays content onto that building there, onto that structure. Sixth Sense. Now, this is a TED lecture that I definitely suggest you all watch. I'm sure many of you have already. This guy, clearly a genius. He's wearing this. He's developed this technology and it's all off-the-shelf components. He's using a wearable projector and a camera. And he's analyzing what's going on in front of him and then projecting things onto those objects. Like here, for example, he picks something up in the store. He analyzes it. Google Goggles might figure out what it is, and then it will project information onto that product about it. So you see he's doing the same here with a book. He's going to go and analyze that, or get his software to analyze that, get the information back about that book and project it actually onto the book. Fascinating stuff. Now, I've touched on goggles already. Now, the technology I discussed earlier is the one with the camera and two little screens on each eye. I've tried that before, it's fantastic, but the way they're going at the moment, there's a lot of research development, a lot of money going into this, is to have the actual goggles. So this is a situation whereby you can actually see through it's like a fairly normal pair of glasses, but it's the information is actually being projected onto the glass itself, so you can see it as you're walking around. And this is completely sci-fi now, but again, a lot of people are actually plowing a lot of money and time into this. The idea of the augmented reality contact lenses. So there's kind of two approaches at the moment, or two kind of ideas. One is to actually overlay content onto that contact lens itself. The other one is to crazily beam the information into your retina directly. I'm not sure I'd fancy that, to be honest, but that seems to be where it's going. Now, all these technologies in themselves are amazing, fantastic. But I mean, what usually happens with technology, like with the smartphone, it all combines into one, essentially. Who would have thought 10 years ago I'd have the internet, the camera, phone, clearly, global positioning, absolutely amazing stuff. So I think even if just a few of these were combined into one device and combined with this, it could potentially, create a fantastic, amazing way of kind of interacting with both ourselves and learning and interacting with the world around us. And that's it. Thank you very much.